Hi everyone, welcome to Go Classes. In this lecture, we will see some guidelines how to check whether a given set of functions, whether a given set of Boolean functions is functionally complete or not. Okay, so these are some guidelines that will help you. Okay, and we will see some examples also. So, what is the first guideline? You can notice minimize the expressions if possible. So, what they will do, so in the question, if they give you some set of Boolean functions, so let us assume this is given. What is given? Given set of Boolean functions. Given set of Boolean functions or Boolean expressions. So let us assume there is a set S that is given to you, and in this set some Boolean functions are given to you. For example, maybe f1, f2, f3, okay, and so on, fn. So let us assume some Boolean functions are given to you, okay, and then question is asking, is this S functionally complete? Is this S functionally complete? This is the question that is asking. Okay, so for example, if they, for example, let us assume they give you this set. Okay, they give you the set and comma or, okay, and they ask you, is this functionally complete? So in this function you can notice, in this set you can notice we have two functions. We have and function, we have or function. So finally in this set what we have a or b, we have a and b. Okay, so these two functions we have in this set, and the question is asking, is this set functionally complete? So how can we answer this question? Okay, so this is the point. So given set of Boolean functions, so this is a set S in which you have Boolean functions f1, f2, fn. These are Boolean functions, and the question is S functionally complete? Okay, so what are the guidelines? The guidelines are very simple. Minimize the expressions if possible. Okay, so if you can minimize, if minimization is possible, then what you do, minimize f1, minimize f2, minimize f3. So minimize all of them. Okay, so this is the first point, minimize the expressions if possible. Okay, so just minimize. And the second point is very simple, that if for all functions f0 is equal to 0, then set is not functionally complete. What I want to say, so basically this is saying that for all functions, so this is our set. You can notice this is your set given to you, f1, f2, f3. Let us assume this is the set that is given to you. Okay, and now the question is asking, is S functionally complete? Is S functionally complete? Okay, this is the question. Now the guideline, you can notice, first what you do, you minimize the expressions. Okay, so let us assume you minimize them. So you minimize this. Okay, just minimize this f1, minimize this f2, and minimize this f3. So finally you have this set in which you have minimized. Okay, so you have g1, g2, g3. Okay, so basically these are minimized expressions. Okay, so you have function f1, f2, f3. Now you are minimizing them. After minimization, this is the set that you have. Now what you do, now you check one thing. What you do, if for all function, if f0 is equal to 0, then set is not functionally complete. So what I'm saying, so if, so this is the point. You can notice, this is the second point. What I'm saying, that if this is g1 for 0 means, when you substitute, okay, g1 0 means when all the variables are 0. Okay, just put all the variables equal to 0. Okay, so when g1 0 is equal to 0, G2 0 is also 0, and G3 0 is also 0. So for example, I am saying that if for all functions, remember, if for all functions in the set, if for all function f0 is equal to 0, then set is not functionally complete. Okay, so this is your set, S. Now I am saying that if for all functions g1, g2, g3, for all of them, if g1 0 is equal to 0, so for all these functions, if you replace the variables with 0, okay, all the variables you replace with 0, and if all the functions become 0, this g1 also becomes 0, g2 also becomes 0, g3 also becomes 0. So if all the function become 0 for this input 0, then I can say that S is not functionally complete. Then this set S is not functionally complete. Okay, and the third point is this. This is the third guideline. The third guideline is, if for all functions, remember again, if for all functions f1 is equal to 1, so for all functions, if you put, so basically if this happens, let's assume if this happens, g1 1 is equal to 1, g1 1 is equal to 1, g2 1 is equal to 1, and g3 1 equal to 1. Okay, so when you replace every variable by 1, okay, just replace every variable by 1. Now if all the functions give you 1, when you replace every variable by 1, then if all functions behave like this, then S is not functionally complete. Then S is not functionally complete. Okay. And the next point is, if every function is self-dual, if every function in the set is self-dual, then set is not functionally complete. Okay. So for example, if you, okay, so basically if every function is self-dual, I can say if G1 is equal to G1 dual, G2 is equal to G2 dual, G3 is equal to G3 dual. So if every function is self-dual, basically, okay, every function in S is self-dual, then I can say S is not functionally complete. So then S is not functionally complete. Okay. So these are the guidelines. Now, if all these guidelines do not work, you can notice if all above guidelines do not work, remember all these guidelines are only one way. Remember, only one way. So basically, if every function is self-dual, then set is not functionally complete. But so this is one way. This is one way only. Okay. But remember, if there are some functions which are not self-dual, then you cannot say that it is functionally complete. So this is one way only. Okay. So these three guideline number 2, 3, 4, this guideline 2, 3, 4, these are one way only. So remember this point. Okay. So remember, this is the note. This is the note. I can say that guideline 2, 3, 4. Okay. Guideline 2, 3, 4 are only one way. Are only one way. Okay. So you can notice if all the functions are self-dual, then set is not functionally complete. But if some of them are not self-dual, if at least one function is not self-dual, then you cannot say that S is functionally complete. Okay. So this is one way. Remember, guideline 2, 3, 4, these are only one way. And now you can notice this is the guideline number 5. If all above guideline they do not apply, if they do not apply, then what you do? Then you try to create not, comma, and, comma, or. Okay. So this is the idea. So if all these guidelines do not apply, then what you do? Then this is the last. Okay. If all guidelines are they do not apply, then what you do? Then you try to create not operation. Then you try to create not operation. Okay. So this not operation you try to create. So this not operation you definitely try to create, and one of them you can try. Either you can create and operation, or you can create or operation. Okay. So either you can create this operation or you can create this operation. So this is the idea. Try to create not operation. Okay. And operation or operation. So if you can create, for example, if you can create not operation or operation, if you can create these two operations, then we can say that the set S is functionally complete. And if you cannot create, okay, if you cannot create one of them, at least one of them you cannot create, for example, let us assume you cannot create not operation, then we can say set is not functionally complete. Okay. So these are the guidelines. Now let's try some examples. On some examples we will see whether these guidelines work or not. So for example, can I say this set, consider this set and, comma, or. Okay. Consider this set and, comma, or. This set, is this set functionally complete? Okay. So this is your set and, comma, or. Is this set functionally complete? Now this set is not functionally complete. Very easily you can see why. Because I told you that if every function, so this is your, okay, this is your set. In this set you have a or b, comma, ab. This is your set, correct? So in this set you have two functions, and function, or function. So these are the two functions that you have in this set S. Now you can apply the guideline number 2. Okay, just apply the guideline number 2. Guideline number, you can notice, okay, what you can do. So this is what you can do. You can apply the guideline number 2. What is the guideline number 2 says? You can notice the guideline number 2 says that this is the guideline number 2. Okay, you can notice if for all functions, when you replace every variable by 0, then if you are getting 0, then set is not functionally complete. Okay, so for all function, so just apply the guideline. This guideline says that for all function, for this function, if you replace these variable by 0, and if for all function you are getting 0, then this set S is not functionally complete. And you can very easily notice that 0 or 0 is equal to 0, 0 and 0, that is equal to 0. So you can notice for all function I can say, okay, so I can say for all function in S, for all function in S, you can notice that f0 is equal to 0, then S not functionally complete. Then S is not functionally complete. So this is the guideline that you can apply. And using the guideline number 2, you can say that this set is not functionally complete. So this set is not functionally complete. So this is the idea. Okay. So this is the simple idea that basically using these operations, OR operation and operation, using these operations, you cannot create NOT operation. Okay. So remember, I am again telling you the guideline number 2. So okay, the guideline number 1. Remember the guideline number 1. What these guidelines are important and they will help you. So the guidelines, you can note the guidelines. The first guideline is minimize. Okay. So this is the first guideline. So minimization. Okay, minimize. The second guideline says that for all functions in set S. So this is your set S. So we want to check whether set S is functionally complete or not. So this set S is functionally complete or not. This is what we want to check. So set S is given to you. Now the second guideline says that for all functions in set S, if f of 0 equal to 0, if this happens for all functions, remember, for all function, if this happens, for all function, if this happens, then S is not functionally complete. Then S is not functionally complete. Similarly, you can notice that, okay, another guideline, the guideline number 3, what is that? The guideline number 3 is, this is the guideline number 3, that for all functions in S, if f of 1 is equal to 1, okay, when you replace every variable by 1. So if f of 1 is equal to 1, then for all function, if this happens, that when you replace every variable by 1, then you are getting the result 1. If this happens for all functions in the set S, then S is not functionally complete. Then I can say S is not functionally complete. Okay. Similarly, the next guideline is for all function f in S, if f of dual is equal to f, means f is self-dual. Okay, what it means? It means for all function, if every function is self-dual, then S is not functionally complete. Then I can say S is not functionally complete. Then S is not functionally complete. Okay, so these are the guidelines. And the fifth guideline is, if these, okay, remember these guidelines are one way. Okay, guideline number 3, guideline number 2, and guideline number 4. So these 2, 3, 4, these guidelines are one way. So if they do not work, okay, 3, 4, 2, if they do not work, then what you do? Then you try to create NOT operation. Then you try to create NOT operation, AND operation, OR operation. Okay, so this is what you try to create. Now let's see one example. So for example, the question is saying none of the multiplication, addition, complement is functionally complete by itself. How can you prove it? Very simple. So you can very easily notice that this and this is not functionally complete. Okay, this is not functionally complete. So what is this? This is your AB, and this is not functionally complete. I can say this is not functionally complete. Why? How can you prove that this is not functionally complete? Very easily you can see that this, okay, you can apply the guideline number 2. What you can do, you can apply the guideline number 2. So the guideline number 2 says that this is the only function you have, only one function we have, and you can notice that this function FAB, you can notice this function FAB, this is your function. You can notice f of 0 is equal to 0. So in this set you only have one function. So I can say that for all function, what I can say for all function in this set S, only one function we have. Okay, so for all function in this set S, I can say that f of 0 is equal to 0. So I can say that so I can say this set S, is not functionally complete. So I can say that this AND operation by itself, this is not functionally complete. So this AND operation alone is not enough. This is the point. This AND operation alone is not enough. Similarly, you can notice that this NOT operation, okay, this NOT operation is also not, this is also not functionally complete. And how can you prove it? So this you can very easily prove that. See, remember, for this guideline number 2 will not work. Okay, because only one operation we have. So in this set we have only one operation. What is that? This is the operation we have, you can notice. So this is the operation we have in this set. And you can notice that this guideline number 2 will not work because you can notice that f of 0 is no, if f of 0 is not equal to 0. Similarly, guideline number 3 will not work because you can notice f of 1 is not equal to 1. So I can say guideline 2. So basically I can say guideline 2 comma 3 do not work, do not apply. Okay, so you cannot, but remember, okay, but remember you cannot say that this is functionally complete. See, guideline 2 comma 3, they do not apply, but I told you these are one way. Okay, so if they apply, then set S is not functionally complete. But if they do not apply, then we cannot say anything. Okay, we cannot say whether this set is functionally complete or not. So let's see whether guideline number 4 will apply or not. So yes, guideline number 4 will apply because this is your set. Okay, and for this set you can very easily see. So in this set we have only one function. You can notice only one function we have in this set. So this is the function we have, this is the function we have. And you can notice this is self dual. You can notice this function is a self dual. This function f equal to a complement, this is self dual because f dual, that is also a complement. The dual of a complement is also a complement. So I can say this not operation, I can say this not operation is a self dual. This not operation is a self dual. And I can say that because only one operation we have in this set and this operation is self dual, so I can say in this set S every function is self dual, so this S is not functionally complete. So this S is not functionally complete. So this is the point. So you can use here the guideline number 4 will work. Okay, because this not operation is self dual, so I can say not operation is not functionally complete. So this not operation is not enough. This is not enough to create, from this not operation we cannot create and we cannot create or. So this is the idea. Okay, let's see some more examples. So you can notice, let's check it out. This set XOR comma or, this set, is this set functionally complete? What is this set? In this set we have two operations. What are those? We have A XOR B and we have A or B. Is this set functionally complete? Let us check it out. Now you can apply again. What you can do, you can apply the guideline number 2. Guideline number 2 you can very easily apply, and you can notice that this guideline number 2 says that you can notice for every function, these two operations, these two functions you have. Okay, this is your function f1. You can notice this is your function f1. So this is your function f1. Let's call it f1. This is function f1, and you can notice this is function f2. This is function f2. So this is your function f2. So two functions we have in this set S. We have XOR and we have OR. And you can notice that 0 comma 0, when you replace, okay, so when you replace every variable by 0, then this is also 0. When you replace every variable by 0, then this is also 0. And when you replace every variable by 0, then this is also 0. So when you replace every variable by 0, then this is also 0. So you can notice for all functions, only two functions we have in this set, XOR comma OR. So I can say for all function, for this, for all of them, what you can notice that, okay, you can notice they are 0 when every variable you replace with 0. So when this A comma B, when you replace with 0, then you are getting 0. So I can say finally that this set is not functionally complete. So this set is not functionally complete. Okay, so this is how you can apply the guidelines. The guidelines are very simple and you can apply them. Let's check it out. XOR comma AND, is this functionally complete? Again, this is not functionally complete because you can apply the guideline number 2, you can apply very easily. Okay, you can notice that these two functions we have AB comma A XOR B, but you can notice that this is also 0 and you can notice that this is also 0. So every function, this function, every function is 0. Every function becomes 0 when you replace every variable by 0. So this function becomes 0, this function becomes 0 when you replace every variable by 0. So I can say that this set is not functionally complete. So I can say this is not functionally complete. What you can do, you can apply the guideline number 2. Okay, using guideline number 2. Using guideline 2. Okay, similarly this example you can check. Okay, in this example you can notice not A bar B bar. This is your set. This is your set S. In this question you can notice that first minimize, of course this is minimized. Okay, so this is already minimized, so this is already minimized, nothing, no minimization is possible. Now you can notice that every function is minimized, this is minimized, this is minimized, every function is already minimized. Okay, so minimization is not possible. Now you can notice guideline 2 comma 3 will not apply, and you can notice that guideline 2 comma 3 do not apply. they do not apply. Why? They do not apply. Why? Because of this not. Okay, because of this not, this guideline 2 comma 3 will not apply, because you can notice that this is your not. For example, this a bar, you can notice this a bar. If you notice this a bar, then you can notice when you replace every variable by 0, then this is not becoming 0. When you replace every variable by 1, this is not becoming 1. So guideline number 2 comma 3, they do not apply. Okay, now but remember, guideline number 4 will apply. So you can notice that guideline 4 applies. Guideline 4 applies, right? Okay, because all of them are self dual. Each of them is self dual. You can notice that. Okay, this function f equal to a, this is self dual because f dual is also a. This function fb, this is also self dual. Okay, this is also self dual. So every function, this function a complement, this is also self dual. Similarly, this function b complement, this is also self dual. So you can notice that every function is a self dual. And you can notice this not function, this not is also self dual, this is also self dual. So you can notice that guideline number 4 will apply. So I can say in this set, every function is self-dual. I can say for all functions in this set S, you can notice that they are self-dual. So I can say S is not functionally complete. So this set S, this is not functionally complete. Okay. So this is the idea. You can check out this. This is also not functionally complete. How can you say? Because two functions you have, one is XNOR and one is OR, and you can very easily see that when you replace them by 1, okay, when you replace them by 1, then they are becoming 1. Okay, both of them are becoming 1 when you replace every variable by 1. So when you replace every variable by 1, then this is also becoming 1, this is also becoming 1. So this guideline number 3 you can apply. Okay, so you can notice this guideline number 3 applies. So I can say so as not functionally complete. So this set as not functionally complete. Okay, not functionally complete. Let's see this XNOR comma and. So again the same idea will apply. This is your XNOR comma and. This is not functionally complete. Why? Because the same idea will apply, that when you replace every variable by 1, then this is also becoming 1, this is also becoming 1. So you can notice both of them are becoming 1. When you replace every variable by 1, then both of them are becoming 1. So I can say for every function in set, this is your set S. For every function in this set S, these are the two functions. You can notice that when you replace every variable by 1, then they are becoming 1. This is happening for every function in set S. So S is not functionally complete. So S not functionally complete. So this is the idea. Okay, so this is how you can check for functionally completeness. In the next lecture, we will take some more examples. We will see some more examples of functionally complete set, but these guidelines are very important. You can notice many questions you can very easily solve using these guidelines. So remember, guideline number 1 means minimization. So first you do the minimization, then second what you do, second you check the guidelines. So this is the first guideline, you can notice. So first you minimize every function, you minimize. So whatever function you have, that you minimize. Okay, so in this set you have many functions. You have function f1, you have function f2, you have function f3. So what you do, you minimize f1, you minimize f2, you minimize f3. Each of them you minimize. Okay, so this is the first guideline. The second guideline is that if every function gives you 0 when you replace every variable by 0, so for every function if behaves like this, then I can say S is not functionally complete. Similarly, if every function gives you 1 when you replace every variable by 1, okay, if every function behaves like this, then S is not functionally complete. Similarly, if every function is self-dual, then S is not functionally complete. And I told you that guideline 2 comma 3 comma 4, they are one way. So if they do not apply, 2 3 4, if they do not apply, then what you do, then you try to create not operation. This is what you try to create. One of them you can create, either you can create and operation or you can create or operation. One of them you can create. If you can create not comma or you can create not comma and, then I can say that this set S is functionally complete. Okay, so these are the guidelines, and using these guidelines you can solve many questions very easily. And in the next lecture we will see some more functionally completeness examples. Okay, thank you everyone.